Welcome back, dear students. So today will be the last video on the second exercise of heights and distance. Okay, so today I am going to take questions from 13 onwards. So let's see, what does the question say? The length of the shadow of a tower standing on a level plane is found to be 2y meters longer than when the sun's altitude is 30 degree than when it was 45 degree. Now the sentence that I have read means that, okay, so let me draw the diagram at the same time. So so there's a plain ground. Okay, so on the ground there's a tower. Okay, so let's say this is the tower. Okay, now there are two cases given, that is when the sun's altitude is 30 degree and 45 degree. So sun's altitude being 30 degree and 45 degree, it means that angle of elevation of the tower is 30 degree and 45 degree. Okay, so that is the meaning of sun's altitude being 30 degree and 45 degree. Okay, so let's say this is the case where angle of elevation or sun's altitude is 30 degree, and let's say this is the case when sun's altitude is 45 degree. Okay, by the way, we have already done one problem where they have talked about sun's altitude. Okay, so right, so let's say that your tower is AB. Okay, so AB is your tower. Now let's say this angle is 30 degree. Okay, and let's say this angle is 45 degree. Okay, and let me call this point to be C and let me call this point to be D. Now what is being said here is, for example, let's forget about this line AC. Okay, then when sun's altitude is 30 degree, then what will be the length of the shadow? Length of the shadow will be dB. Okay, now if the sun's altitude is 45 degree, then length of the shadow is going to be BC or CB. Okay, then obviously you see that dB is longer than BC, isn't it? Shadow dB is longer than shadow CB. Now by how much? By how much dB is longer than BC? It is given that it is longer than dB is longer than BC by 2y meter. So basically what is given here is dB minus BC, and dB minus BC is given to be 2y. Okay, now what we need to prove here is, we need to prove that the height of the tower is y root 3 plus 1 meters. Okay, so that's what is the height, and we need to prove it, in fact. Okay, we need to prove that the height of the tower is this much. Okay, so since I don't know what is the height, what am I going to do is, I'll take the height to be x. Okay, so let the height of the tower be x, and what's the unit being used? Unit is used as meter. Okay, now let's observe two triangles out here. Okay, so in triangle you have let's say the smaller triangle. So in triangle ABC, so let's make use of this concept. So AB by BC. Okay, so we have AB by BC, perpendicular by base will be tan theta, whereas in place of theta we have 45 degree. Okay, let's put the values. So AB is x by BC, we don't know what is BC, so tan 45 is 1. So from here you see what is BC. From here you see that BC is x meter by cross multiplication. Okay, now let's observe another right angle triangle. Okay, so in triangle ABD, okay, so in triangle ABD, again let's make use of the same concept, that is AB by BD or DB. Okay, let's say BD. So again this time this is also tan theta, perpendicular by base, but here in place of theta we have 30 degree. Okay, now AB is x, all of you know this. BD I don't know, so from here tan 30 degrees 1 by root 3. So from here what is BD? from here BD turns out to be root 3 into x, that is root 3 x meter. So I got BD also. Okay, now see here carefully, since we have dB minus BC is equals to 2y. Okay, we know all this thing, right? So from here what am I going to do is I'll put the value dB or BD, which is root 3 x. Okay, minus what is BC? BC is equals to x, isn't it? So x is equals to 2y. Now from here you see x is common, right? So x is common, so you get root 3 minus 1 common, root 3 minus 1 here is equals to, you get 2y. Okay, now since you need to find the value of x, which is the height of the tower, now when it goes through the denominator, okay, you get 2y by root 3 minus 1, but we don't have such kind of case here. So what am I going to do is I am going to multiply both sides by one quantity. Okay, so see here carefully, multiplying both sides by, I want this quantity, so that's why I'm going to multiply both sides by root 3 plus 1. So let's see what do we get. Then we get here x into root 3 minus 1 into root 3 plus 1, okay, is equals to 2y into root 3 plus 1. Okay, now this is in the form of a minus b into a plus b, and all of you know a minus b into a plus b is a square minus b square is equals to 2y into root 3 plus 1. Okay, now simplify this, x into, so root 3 square is 3 minus 1 square is 1, so this is equals to 2y into root 3 plus 1. Okay, now how much is this? So this is 3 minus 1 is 2, so we have 2x is equals to 2y into root 3 plus 1. Now 2 and 2 can be cancelled, so from here what do you observe? You observe that x is equals to y into root 3 plus 1. And what is x actually? X is the height of the tower, and we showed that the height of the tower, that is x, turns out to be y into root 3 plus 1, and that's what we wanted to show, isn't it? So at last we'll write, so therefore you will write this at last. Okay, so therefore height of the tower is y into root 3 plus 1 meters. Okay, so that's what we need to write at the end. Simple. So you may pause the video and note down your solution. Let's move to next question now. So question says, an aeroplane flying horizontally 1 kilometer above the ground and going away from the observer is observed at an elevation of 60 degree. Understand the situation out here. So there's a ground first and foremost. Okay, so let's say that this is the ground, and let's say that observer is somewhere out here. Okay, and he observes that the aeroplane is at an angle of elevation of 60 degree. Okay, and the height of the aeroplane is given to be from the ground, this height is given to be 1 kilometer. Understand the situation out here. Okay, so height is given to be 1 kilometer. Okay, and angle of elevation is 60 degree. Okay, now since the aeroplane is going away from the observer, okay, then what happens is, see, the height of the aeroplane is being maintained at 1 kilometer. So after 10 seconds, okay, so let's say after 10 seconds the aeroplane reaches somewhere out here. Okay, so that time also your height is going to be same. Okay, but that time what happens is your angle of elevation changes, and it changes into, okay, so this angle of elevation changes to how much? It changes to 30 degree as per the question. So that means this angle, so this angle is 30 degree. Okay, now question is asking, see, this is after 10 seconds. Okay, after 10 seconds, so basically the position of aeroplane is being changed. Okay, now question is asking, find the speed of the aeroplane in kilometer per hour. Okay, so first and foremost, let me quickly write down or label it. Okay, so ABC, you can call this DE. Okay, right. Now question is asking you to find speed, right? So all of you know speed can be calculated using this formula, that is speed is equals to distance by time. Okay, time is given to be 10 seconds, so we don't have any problem. But what is the distance covered in 10 seconds? Distance covered in 10 seconds is BE, isn't it? So basically our aim is to find the distance, which is BE. Okay, so we'll find BE. Time is already given, which is 10 seconds. Simple, right? So for that, again we'll make use of the concept of the height and distance. And remember DE, the height of the aeroplane, is also again 1 kilometer. So you have got two triangles out here. Okay, so let's observe one triangle at a time. So in triangle, let's say ABC. Okay, so in triangle ABC, so AB by BC, okay, AB by BC is perpendicular by base, which is tan theta, and tan theta is tan 60 degree in this case. Okay, so we have AB. What is AB? AB is 1 kilometer. Okay, and BC is not known. So from here tan 60 degree, all of you know it is root 3. So from here you see what is BC? BC turns out to be root 3. I'm sorry, BC turns out to one minute. Okay, so you have BC equals to, so when you do the cross multiplication, you get 1 by root 3 kilometer. So this is your BC. Okay, now we'll observe another triangle, triangle DEC. Okay, so in triangle DEC, so again you have DE by CE or EC, so you call CE is again perpendicular by base, but this time it is tan theta is 30 degree. Okay, let's put the value. So DE is 1 kilometer by CE, we don't know what is CE, is equals to, it is tan 30 degrees 1 by root 3, isn't it? And from here you see that CE turns out to be root 3 kilometer. Okay, so I got the value BC and CE, and what is my aim? My aim is to find what is BE, isn't it? So therefore BE, so can I say that BE is CE minus CE minus CB? Yes, so BE is nothing but CE minus CB, or you can call it BC. Okay, now what is CE? CE is root 3 minus what is BC? BC is 1 by root 3. Okay, let's simplify. So LCM is root 3. So you get root 3 into root 3 is 3 minus 1. So this is 2 by root 3. So we got our BE also. Okay, now given is time. Time is given to be 10 seconds, isn't it? So we have time given to be 10 seconds. Now if you convert this into hours, first you have to divide 10 by 60. So when you divide by 60, you get minutes. Okay, so we have to divide it again by 60 in order to get hours. Try to understand. When you divide 10 by 60, you get minutes, but we have to again divide it by 60 so that you get your seconds into hours. So this and this can be cancelled. So basically time is given to be 1 by 360 hours. Okay, so we got the time, we have got the distance. Okay, so therefore speed. Okay, now why am I calculating in hours? You know, because speed is asked to be in kilometer per hour. We have distance in kilometer, time also has to be in hour. Okay, so speed is equals to, all of you know, it is distance by time. Okay, so distance is 2 by root 3. You write this division as into time is 1 by 360. So this can be written as 360 by 1. Okay, so you just what you can do here is, okay, so you can do rationalization. Okay, that will be better. So what am I going to do is I'll multiply both numerator and denominator by root 3. Okay, so what do we get? Let's see. So you get 2 into 36 is 720. Okay, so 720, and we have root 3 also. In the denominator we get root 3 into root 3 is 3. So you can cancel with 3 now. So 3 1s are 3, 3 2s are 6. Okay, so we have got 1 left, so goes here 12, 3 4s are 12, so we have 0. Okay, so basically you get your answer to be 240 root 3 kilometer per hour. So this is the, this is the speed of the aeroplane in kilometer per hour. Simple. So you may pause the video and note down your solution. Let's see the last question from this particular exercise. Alright, so question says, from the top of a hill, the angles of depression of two consecutive kilometer stones due east are found to be 30 degree and 45 degree respectively. So I hope you know where does east lie, because they are talking about east. So east lies this way. Okay, so there's a hill. Okay, so let's say that this is the top of the hill. Let's say this is the top of the hill. Now there are two consecutive kilometer stones. I hope you are familiar with what is kilometer stones. While traveling, you see at some places you have one stone where your distance will be written. Okay, that is called kilometer stones. So there are two consecutive kilometer stones and their angle of elevations, angle of depressions are given. Okay, so let's say this is the angle of depression. Okay, so let's say this is the position of first kilometer stone, and let me take another consecutive kilometer stone to be this one. Okay, now angle of elevation and angle of depression, all of you know that both of them will be equal to each other, isn't it? So that's why I'm going to directly write down your angle of elevation out here instead of angle of depression. Okay, so this angle is obviously 45 degree. You can take this to be 45 degree and this can be taken as 30 degree. Whichever is smaller, whichever seems to be smaller, that has to be 30 degree, and whichever seems to be bigger, that has to be 45 degree. So let's say AB is the height of the hill. Okay, now let me call this to be C and let me call this to be D, where C and D are the positions of two consecutive kilometer stones. That means if it is, since it is written consecutive means immediately next, remember that. So that means if 5 kilometers written out here, then it has to be here 6 kilometer. Okay, so basically what is the distance between C and D? It is exactly 1 kilometer. Okay, now question is asking you, find the distances of those two stones from the foot of the hill. So basically you are asked to find what is BC and what is CD. Alright, so for that, what you can do here is you can take BC to be X. Okay, so let BC equals to X kilometer. Okay, then can tell me what will be BD. Then BD will be, if this is your X kilometer, then it will be X plus 1 kilometer. Simple, it will be X plus 1 kilometer. Okay, now using these two, what am I going to do is I'll find the height from both the triangles. Okay, so let's observe the first triangle ABC. So in triangle ABC, we have AB by BC. AB by BC will be tan 45 degree. Simple, right? So AB is how much? AB I don't know. We have to calculate AB. But we know BC is X. So from here you get tan 45 is 1. So from here you get AB is equals to X into 1 is X. So AB will be X kilometer. Okay. Now we'll observe another triangle ABD. Okay. So in triangle ABD, now again we'll find what is AB from this. Okay. So you can call this, by the way, equation number 1. Okay, so we have in triangle ABD, AB by BD will be equals to tan 30 degree. Okay, so AB, all of you know, we'll write it as it is. We'll keep AB as it is. Or what you can do here is you can write AB as, how much is AB? AB is x, right? So you can write AB as x, and you know what is BD? BD is x plus 1. Okay, is equals to tan 30 degree. What is tan 30 degree? It is 1 by root 3, isn't it? So from here, let's calculate what is x. Do the cross multiplication. So root 3 x is equals to x plus 1. Okay, so again you get root 3x, bring this x out here, minus x is equal to 1. So x is common, so you get root 3 minus 1 is equals to 1. Okay, so you have, see here very carefully. So you know, okay, just wait a minute guys. So here what you can do is, so you have root 3 is 1.73, you know, right? So put the value root 3 as 1.73. So if you do that, let's see what do we get. Or else what you have done earlier, remember, you can do the same thing here also. Okay, so you multiply both side by root 3 plus 1. Okay, so when you multiply both side by root 3 plus 1, let's see what do we get. So you get x into root 3 minus 1 into root 3 plus 1 is equals to 1 into root 3 plus 1. I have multiplied both side by root 3 plus 1. Now all of you have seen that this will be root 3 square minus 1 square is 1 into root 3 plus 1 is root 3 plus 1. Okay, so how much is this? This is 3 minus 1, which is 2, right? So this is 2, and now we can put the value of this to be 1.73 plus we have 1, okay, which is 2.73. So from here, you know, x comes out to be 2.73 divided by this 2 goes to the denominator. Okay, so divide 2.73 by 2. So then you get your answer to be 1.365. Okay, so this is the value of x. Okay, so since we got the value of x, what is x actually? X is BC, right? So therefore BC turns out to be 1.365 kilometer. And what is BD? Then BD turns out to be 1.365 plus 1, which is 2.365 kilometer. So these are the distances of the two stones from the foot of the hill. Okay, I hope you have understood the sum. So with this, we close this particular exercise from height and distance. Okay, you may pause the video and note down your solution. Thank you very much.